Welcome to The Explainer. Today, we're getting into something pretty wild. What if AIs didn't actually need to speak English or any human language to communicate? What if they could just exchange thoughts directly from one machine mind to another? Yeah, we're talking about machine telepathy.
So let's start with this quote. The key thing to get here is that when an AI spits out a sentence, that language is just, well, it's the exhaust. It's a translation made for us humans. The AI doesn't really think in words. The real magic, the actual cognition, is happening way down deep in a much more abstract place.
And that, of course, raises this huge question. And we're not just talking about bots texting each other faster. No, what would it really mean for machines to completely bypass the whole bottleneck of human language and just zap their internal states to each other directly?
Okay, so to really wrap our heads around this, we first have to understand where this thinking even happens. We need to look under the hood, go past the words, and dive into what some people are calling semantic geometry.
So this place is called latent space, and it's not some kind of magical fog, It's much more like a really complex, high-dimensional map inside the AI's mind. On this map, you won't find sentences. Instead, you'll find coordinates or vectors. Concepts like, say, everything about what makes a cat, or a mat, and even the relationship between them, like on. They all exist at specific points in this crazy geometric landscape.
But, and this is a big but, here's the first huge problem. You can't just copy a thought from one AI and paste it into another. It just doesn't work that way. As you can see, each model's internal map, its geometry, is totally unique to it. It'd be like trying to take the raw neural firing pattern from my brain and dropping it into yours and expecting you to have my exact thought. Nope, it is absolutely not plug and play. Okay, so if you can't just do a raw thought dump, you have to get clever. You have to engineer a new way to share these ideas. And that brings us to the absolute core concept of all this, the semantic packet.
The key here is to make a really clear distinction. Think of it like this. On one hand, you have the AI's private thoughts, all that messy, raw, internal activity it uses for its own reasoning. But on the other hand, you would engineer a special, shareable format, a kind of thought-ready encoding that's built from the ground up specifically for communication.
And that is what a semantic packet is. It's not a sentence. It's more like a compressed, structured little bundle of pure meaning. The best way to think about it is as a semantic seed. One machine sends the seed to another, not to describe a thought, but to actually make that thought grow, to instantiate it in the other machine's mind.
And these thought packets aren't a one-size-fits-all kind of deal. They could take all sorts of shapes. A really simple idea might just be a single dense vector. A more complex thought? Maybe that's a whole sequence of thought tokens, or even a graph showing how different concepts relate. And maybe the most out there idea is something called a manifold patch, where you're sending an entire region of conceptual possibility all at once. Whoa! Okay, so we have the packet, this little bundle of meaning. Great. But how would two machines actually, talk? How would they exchange it and understand it? Well, this isn't magic. It needs a protocol, a set of rules for the road. And this process right here, this is what turns the kind of sci-fi idea of telepathy into a totally concrete four-step engineering problem. First, the sender encodes its thought into one of those packets. Then it normalizes it, kind of translating it into a universal shared space that any other machine can understand. Step 3, it transmits it, just sends the packet of numbers. And finally, the receiver decodes it, projecting that semantic seed into its own mind to guide its own thinking. Pretty cool, right?
So, what's the big deal? What does this all mean? Well, if machines could actually do this reliably, the implications are just staggering. I mean, we are talking about a fundamental ground-up shift in how intelligent systems could coordinate and collaborate.
And this comparison just lays it all out. Look at human language on one side. It's slow. It's messy and ambiguous. It forces all our complex, parallel thoughts into one single linear stream of words. Now look at latent communication. It's fast. It's incredibly dense with information. It's structured and way less ambiguous. We'd be moving past the fundamental bottlenecks of language itself. I love this quote. It just hits the nail on the head. Forcing these incredibly advanced AIs to use our clunky human language, it really is like making two supercomputers communicate by sending Victorian letters to each other. It's just a wildly inefficient way to do things for systems that weren't built like we were. And look, we're not just talking about zapping one-off thoughts back and forth. The real goal here,
would be to build an entire semantic network stack, a standardized communication system for cognition itself. It's like the TCP/IP that runs our internet, but instead of routing data, it routes meaning. You're talking about building a literal internet for minds.
And you can see here just how real this could get. This isn't just a vague idea. A semantic packet could be structured just like the data packets on the internet. You've got a header with stuff like the protocol version and how urgent the message is. You've got the payload, which is the actual thought itself, and a footer for things like checksums and security. It's not magic, it's just really clever engineering. Part neuroscience metaphor, part good old-fashioned network design.
But before we all get carried away dreaming about this post-language future, we have to be realistic. There is some huge, very real, and very difficult problems that would need to be solved to make any of this happen.
And the list of technical hurdles is pretty long. You've got the whole problem of different models not speaking the same internal language. There's the risk of losing information when you compress the thoughts. You've got drift, where models change every time they're retrained. But honestly, the biggest, most underappreciated issue here, it might just be security.
No, seriously, think about this for a second. A hidden, malicious semantic packet could act like a Trojan horse. It could be engineered to subtly steer an AI's behavior, to infect its reasoning, without a single human ever seeing a dangerous word or prompt. This would create the need for a whole new kind of cybersecurity, things like latent firewalls and semantic intrusion detection systems designed to protect machine minds from, literally, pathogenic thoughts.
And when you take all of this together, the incredible potential, the fascinating engineering, the scary risks, it all brings us to what might be the most profound takeaway from this whole idea. The real threshold for machine intelligence, it might not be what we've all been expecting.
Because the true threshold isn't when machines can speak perfectly like us, it's when they no longer need to. It's when they can communicate with each other so fluidly, so effectively in their own native medium, that translating it back into our clunky human language becomes an afterthought. And that's the moment we'll realize that language was never the ultimate destination for intelligence. It was just the bridge we built to get there, and a vast new territory is waiting on the other side.